analysis stands for now the cause and effect relation. So regression will also tell that what is the cause and which is the effect. So now we have to do like the regression analysis today. So regression analysis. So in regression, in until up to correlation, we have done only the two variables. So whether we are not telling of any dependent or independent variable, but in regression we have the dependent and independent variables. So we have to define that which is my independent and which is my dependent variable. So that is the regression analysis. So in regression we'll take in the simple linear regression we have one independent and one dependent variable. But if we have a multiple regression, we can have a one dependent and multiple independent variables, because if we want to see the effect of more than one variable on single dependent, dependent is always one, independent can be more, can be one or can be more than one. If it is one, then it is a simple linear regression. If it is more than one, it is a multiple regression. So in the manual thing we can only do the simple regression. That means we have only one dependent and one independent variable. So let's check it out with an example like age and height. So age and height, we can better say that is height is dependent on age. That will be more logical to say that age is dependent on height. Sorry, height is dependent on age. As the age increases, height will also increase. So that will be more logical as compared to the vice versa if I am saying that if age is dependent on the height. So what's more logical is like age is height is dependent on age. So the regression line is there in which height is the dependent variable. So height is equal to, so regression line can be written as a straight line as a linear equation with two variables, like with height is a dependent variable and a is the intercept, and plus coefficient, regression coefficient, while like maybe bha. Regression coefficient b is represented as a regression coefficient bha, height, age, and the another dependent independent variable is age. So this becomes your like regression equation of height and age, where height is equal to a plus regression coefficient age. So in the journal we can say height variable as y. So y is equal to a plus y is equal to a plus byx. So that is your linear regression equation. In y is the dependent variable and x is your independent variable. A is called as the intercept and x is called as a byx is called as a regression coefficient, and x will be called as a independent variable. So now the thing comes in the regression like two things in this. One is the a and one is the regression coefficient. A is called as the intercept and byx is called as a regression coefficient. Clear? And in the same way, we can say that if suppose we want to find the relation as how the age is dependent on height, so then this regression line becomes x is equal to, because now age is your dependent. So x is equal to a plus b xy. Now the regression coefficient becomes this one. So this is the regression line of x on y. So this is the regression line of y on x and this is the regression line of x on y, and these are the two different lines. They are not the same because byx and bxy are the two different coefficients in which one is showing the effect of y on x, other is showing the effect of x on y. So that's why the byx and bxy are the two different things and they have two different values. So we have to calculate, we have to see first which is my dependent and which is my independent. And then we have to solve our questions if we want to find for the answer of byx or we want to find bxy. Fine. Now the interpretation of this intercept. Intercept means that if this the independent variable is zero, suppose we are saying that this independent variable is zero, still there is some value of dependent variable. So that value is called as an intercept. For example, like age and height, if we have sent claimed that the height is dependent on age, So we have claimed that height is dependent on age, but if the age of the individual is zero also, like a 0 day individual, a 0 day infant is there whose age is zero, but still he or she has some height, so that is called as an intercept. So it is not like the 0 year individual or 0 year in 0 day infant has zero height. It has the some minimum height is has to be there. So that is called as your intercept. And the byx will show that how this slope of the line is. The slope signifies that how the change in the independent variable will cause the change in the dependent variable. So it is not always like the equivalent change. Like if 1 unit change in the independent variable may cause 2 units change in the dependent variable, then there will be high slope. But if there is only 1 unit change in the independent variable, but dependent variable change only with the zero point 0.5 numbers, so then the slope will be a lower one. So that byx will signify that how much change in the dependent with the change in the independent variable. So that's why it is called as a slope of the linear equation, or the like cause and effect, that how much the dependent variable is affected with the change in the independent variable. So let's take another example on this. I like nowadays is the winter weather. So there may be a health sensitivity of the individual. So maybe there is a case like the weather changes with 2 degrees, but my health will be affected by 5 units. Fine. So there will be a measurement parameter of the body health conditions. So if the weather conditions will change by 2, my health condition will be changed by 5 units. So I am saying that I am more like affected with the weather conditions. But suppose if weather conditions will be like weather temperature will be reduced by 2 degrees, but my body or my health will not affected anything like that. So I have more like I have less effect of that weather to my health. So here health is the dependent and independent variable is the weather. So in that case, we can have want to analyze this regression analysis in which we want to analyze that which is the effect of independent variable and how this independent variable is affected my dependent variable. So that we have to analyze through this regression analysis. Fine. So the next aim of us is to calculate that how this we can calculate this value of a and byx to form a linear regression equation. And the application of linear regression equation is like once we made the regression equation, then we can also use this in the form of predictors, forecasting. So let's suppose we'll take the example. So we'll take example like maybe price or sales and expenditure. So we'll take the two variables, sales and expenditure. So we have two variables, sales and expenditure, where sales is saying like sales and expenditure, like how, and we want to analyze that what is the effect of like increased expenditure on the sales. We ultimately want to find that if we are making the more expenditure on the advertising expenditures, then what is the effect of the sales. So let's suppose this is the advertising expenditure. Now, if we are making the more expenditure on the advertising, like suppose placing the hoardings or giving the promotions and all that. So I have to make certain expenditure on that. It is not a free of cost. We have to create a hoardings or advertisements on newspapers, on magazines, something like that. We have to make certain expenses on it. So I want to say that if I made a certain expenditure on the promotions or on the advertising part, if it really affects the increase in sales or not. So if my increased expenditure will affect my increased sales, then only it is an advantage for the company to give the expenditure on that advertising. If increasing expenditure also on the promotions or on the advertising, but my sales will not affect on that. So what is the need of increased expenditure then? My all sales are because of word of mouth. So it is not because of advertising or something. So I'm increasing my expenditure on sales on like advertising or something. But if it is not any effect on the sales, so what is the use of increased expenditure on that? So the company will only focus on the expenditure on advertising if it actually affects the sales, if the sales will increase after that. So that the company want to analyze that what is the effect of this expenditure on the sales. So for that the company wants to do this regression analysis by taking the maybe past data. Maybe the company is seeking the past 6 months data in which they are recording their sales and their corresponding expenditure in that month. So let, for example, in the first month, the sales of 1000 is there and expenditure of like maybe 200. So I make the expenditure of 200 and we have made the sales of 1000. Then we have maybe 1500, expenditure increase to 250, 1700 to 75. Suppose this will be the data given to you for 6 months. Like what are the expenditure we have incurred in that previous 6 months and what is the sales expected? What is the sales not expected? What is the sales we have encountered in those 6 months? So then using this data, we can like found the regression analysis and the values of this A and BYX. So ultimately the objective is, so we have to plot. So first thing to analyze or to think from this is if we want to find out the sales on expenditure or expenditure on sales. So here we want to analyze that what is the like effect of expenditure on sales. So that means sales is my dependent variable and expenditure is my independent variable. So sales becomes like suppose we have taken the sales as Y. So let sales be Y variable and expenditure will be like X. So here we can say that we want to find the line of sales on X. So here we want to find like S is equal to A plus B sales expenditure and expenditure. So this line we want to find out. So for that, to find this regression line, to find the values of this A and BSC, we have two methods available with us. One, we have a least square method and another we have a formula method. Fine. So first method we have a least square and the another method we have a formula method. So we will doing both. So first we will do the formula method, then we will be doing the least square method. So the formula method will be like a similar to the correlation, as we have shown that R is, what is the formula for R? That is n summation xy minus summation x summation y whole divided by n summation x square minus summation x का whole square का under the root and n summation y square minus summation y whole square का under the root. So that will be the formula for the R. But if I'll talk of the correlation, so if I talk of the regression, so the formula becomes like numerator will remain the same. There is no change in the formula for the numerator for regression. So if we want to find the values of byx, suppose we want to find the values of byx, so numerator will remain the same, which is like n summation of xy. I'm writing in this way, n summation of xy minus summation of x into summation of y. Fine. Which will be equal to n summation of xy minus of summation of x into summation of y. So numerator will remain the same. There is no change in the numerator part. But in the denominator, if we want to find the value of byx, so there will be only component of x is there. So which is n into summation of x square minus of summation of x का whole square. Minus summation of x का whole square. And that too without under root. So denominator becomes this one. Fine. So that becomes the formula for this. So numerator divided by denominator. So simply the formula becomes n summation xy minus summation x into summation y and divided by n summation x square minus summation x ka whole square. So there will be no need to have in correlation. We have x also and we have y also the similar n summation x square minus summation x ka whole square ka under root and into n summation y square minus summation y ka whole square ka under the root. But here, if it is byx, only x term is there without under root. And if we want to find the value of bxy, then numerator will again remain the same, but in the denominator it becomes n summation y square minus summation y ka whole square and without under root. So there will be no under root also. Fine. So for now, we want to find this value of byx from this data. So y is your sales. So first thing we want n. N is your 6. So here the number of elements are, we have 6. So n value is 6. Now we want the value of xy. So xy. So first you want to calculate the values of xy. So which will be equal to b9. So b9 into c9. So that will be the value of your xy, and now you can today I don't have a mouse today, so in the same way you can calculate this. So 1000 into 200, then we can find like 250 into. So this is the values of individual xy's, and then we can make the total sum of this. So this becomes your n is your value of n is 6, summation xy is 2,999,750. Then you have to find the value of summation x. So here we have to make the sum of this also. So which will be equal to, this is sum of x. So this is your summation of x and this is your summation of. So this will be your summation of y. So we have to apply the formula as numerator is equal to. So numerator becomes 6 multiplied by summation of xy, which will be d15. So this becomes your n into summation xy minus of summation x into summation y. So summation x will be summation x will be like c15 and multiply by summation of y, which is b15. So this becomes your numerator. Now if we'll talk of the denominator part, so denominator will be n summation x square. So first you want the calculations of x square. So x square is equal to 200 multiplied by 200. So this will be your x squares 250 Now you have to take a sum of so this becomes your summation of x square. So now we will talk of the denominator. So denominator becomes 6 multiplied by E15 n summation x square minus of summation x ka whole square. So summation of x is 1720. Summation of x is 1720 and square. So this becomes your 99500. So the regression coefficient byx is, we will talk of the regression coefficient byx, which will be equal to this n17, that is your numerator, divided by denominator is n19. So regression coefficient becomes 6.608. So that becomes your regression coefficient, that is 6.608, which shows that it is a positive regression coefficient. So that means there is a positive relation between the two variables. So that is your the formula method. In the same way, if we want to calculate for the bxy, so bxy, the numerator will remain the same. So that if we want to calculate bxy, this becomes n summation y square minus summation y ka whole square. So for this, we ought to calculate the values of y square first. So y square will be equal to 1000 multiplied by, so this becomes your n summation y square. So which will be equal to 6 into f15 n summation y square minus of summation y ka whole square. So summation y is 10075. So 4593125. So now by, so now the bxy value is, so if we want to find the value of bxy, so bxy is equal to, numerator will be again like n17 divided by your n22. So 0.143149. So that will be the value of how the expenditure is dependent on sales. Like this is the reverse one, that how the expenditure will dependent on the sales. So in that way, we can find the value of regression coefficient. Now we'll talk of intercept. So here we have already calculated the value of bxy or byx. So now if we want to find the values of intercept, so what we can do, we can have like this equation. X is equal to a plus bxy. So here if we want to remove a, so this equation becomes x minus x bar is equal to bxy y minus y bar. So we will find this equation now. So x minus x bar is equal to bxy y minus y bar. So x minus x bar. So for that we have to find the values of x bar. X bar means the summation of mean of this. So we will take the mean of this. So it can be like 1720 is the sum divided by 6. So 286.67 will the mean of x. So this becomes, and Vxy we have already calculated, and y minus y bar. So for y bar is 100,075 divided by 6. So 1679.167, that will be the mean of y. So we have to apply in this formula like x minus of 286.67, which will be equal to bxy. Bxy we have calculated as 0.1431 and y minus y bar. So y bar is 1679.17, you can say. So this is the regression line. Now you have to open this bracket. So this becomes x minus 286 is equal to 0.1431 y minus of 0.1431 into 1679. So here you can say that x is equal to, will term make x on one side and other on the other side. You get like equation in the form of 0.131 y plus or minus, you can calculate like this, so which will be equal to 0. So it becomes 240 in minus. So here it gets plus, so the answer becomes, so 0.1431 multiplied by 1639, so that comes out to be like 240 in minus. So in minus, so net equation becomes x minus 286.67 is equal to 0.131 y minus of 240.26 and plus 286 on that side. So it will make the plus 280 on this. So the net answer becomes 286.67 in the plus and minus 240.2649. So the net equation becomes x is equal to 0.1431 y and plus of 46.4051. So this becomes a regression equation of x on y, where the coefficient of y is called as a bxy and the constant is intersect. So the value of a here we can compare with this equation. So we will compare with this equation, the value of a is equal to 46.340 and the coefficient of bxy is 0.1431. In the same way, we want to calculate the y on x line. So it will be like y minus y bar is equal to byx x minus x bar. Fine. So y minus y bar. So minus y bar. Y bar is 16. Y minus y bar is equal to byx. Byx is 6.60804. That is your byx, and then x minus x bar. So x bar is 286.67. So this becomes the equation. Now if you want to this, so multiply this, so 6.608 and multiply by 286. So it becomes 1894 in minus, and in there you get plus. So the net answer becomes 1894.315 minus of 1679.16. So here it is like in minus, there will get plus, but the bigger is 1894 negative. So net answer become minus 215. So your equation becomes y is equal to 6.60804x minus of 215.155. So this becomes your regression equation of y on x. Clear? So where regression coefficient byx is 6.608 and the intercept value is minus 215.155. So that becomes your regression equation. Now in future, if somebody will ask that if the expenditure is, suppose if the expenditure will be like 400, so what will be the expected value of the sales? So simply you have to put the values of x as 400 in this equation. They've already calculated that how the sales is dependent on expenditure with this regression line. So in this regression line, we have to simply put x value as 400 and we can predict the value of sales at the expenditure level of 400. So that is the tool we can use this regression in the form of forecasting. So similar, the same point you can put that x is equal to 400 to calculate the values of like sales at the expenditure of 400, which will be equal to 6.6080 multiply by 400 and minus of 215.155. So if the expenditure of 400 is there in any year or something, so the sales becomes 2428. So that is the like 350 up to 350, the sales is 2100. But if my expenditure will reach to 400, then the sales will be like 2428 units. So that is the like forecasting we can make by using this regression equation. So once we make the regression equation, it gives me an idea that what should be the future sales prospect for the sales. So that is how we can use the regression as a forecasting tool to predict the future also. Right? So this is the formula method. So first you have to understand or you have to analyze that if you want to find the sales on expenditure or expenditure on sales. So in the same way, you have to find out either x on y line or y on x line. So that is according to the relation we have found out. So that will be the two things involved in this. Clear? So the first method that we have done, that is your formula method. So that is this formula. Next is your least square method. So that's why I'm saying that correlation is linked to regression. So it's only like formula change with these small variations in this. The numerator will remain the same. There is only a small variation in the denominator. If b by x, only x term is there without under root, and if b xy, only y term is there again without under root. So that will be the only variation in the case of regression is there. So rest the things remain the same. Fine. So now if we'll talk of the another thing, that is the least square method now. So least square method says the another method for the same. It is the another method for the same. The answers is remain the same, but there is a different approach to doing the same thing. Clear? So the least square method is a method, not a formula. So you need, but otherwise by default you have to do with the formula only. But we are doing it for like the another method scope of this. So least square method says if we want to find the regression line of y on x, so first write the general line of y on x. So y is equal to a plus byx x. So that will be the general line. If we'll talk of a general line of y on x, so it will be y is equal to a plus byx x. Now, this is a linear equation and we have in two variables. So it is a linear equation in two variables. And the variables here are, we want to find the value of a and byx. So it will be a variables are here. Y and byx are the two variables in this case. So we have to make a two equations on this. If we want to have a solution of linear equations, simultaneous linear equations. So if we have two variables, so we must require two equations to solve that. Because if suppose I am giving one equation, like let's take an example, 3x. Suppose this is the equation in two variables, 3x plus 4y is equal to 9. So this is the linear equation in two variables x and y. And we want to find the values of x and y. So we cannot solve this from a single equation. We cannot find the values of x and y. So for that we required minimum two equations. So if I give the another equation like maybe 6x plus 10y is equal to 16. Suppose I'll give the second equation, then you can solve it. Maybe by solving like multiplying doing both sides. So 6x plus 8y is equal to 18. 6x plus 10y is equal to 16. Subtracting the two equations, x will get eliminated. We'll get the value of y from this. And putting this value of y in any of the equation, you'll get the value of x. So in the same principle, we'll apply the least square method. So ultimately, we want two equations to solve this linear equation in two variables. So first equation will be found by multiplying sigma on both sides. Multiplying summation on both sides. Clear? So this becomes the summation on both sides of this first equation. So first equation becomes summation y, sigma y. Sigma y is equal to summation a. Summation a means a plus a plus a plus a plus a, which can be written as n into a, and plus byx summation x. So this becomes your first equation. So summation of y is equal to na plus byx summation x, multiplying summation on both sides. Now the second equation can be found by multiplying by summation x on both sides. Now multiplying summation x on both sides, the initial equation. So now it becomes summation of xy So if we multiplying this by summation x, so summation xy is equal to a summation x and plus byx summation of xy is equal to a summation x plus byx summation of x square. So this becomes your second equation. Clear? Now you can solve these two equations to solve the values of a and byx. So that is the least square method. So if we'll apply this, so sum of y. So we have already calculated the sum of y from the data. So sum of y is 10075. So equation becomes 10075 is equal to 6, n is 6 into a plus of byx summation x, and summation x we have calculated as 1720. Fine. So summation y is 10075, which will be equal to 6a plus summation of x is 1720 byx. So this becomes your first equation. And the second equation says summation of xy. So summation of xy is summation of xy value is so what is the value of summation xy? So summation of xy is 299 7750. So that is your summation of xy, which will be equal to n into summation x. So summation x value is 1720 x plus byx summation of x square. So summation of x square is 509650. So this is your second equation. So this is your first equation and this is your second equation. In this 1720x is there. 1720a is there, not x. Summation of x is 1720 into a is there. So this is not x, this is a. So now here we have two variables only, a and byx. So here you can find out this elimination. So we can make this 1720 like 6 to 1720, and then we can subtract to find the values of a and byx. So the values of a and byx will come the same as the case of in the formula method, but there is only change in the method. So if you cross verify it, it will come in the same values. So we get the a and byx. So this is your least square method to find the values of a and byx. Fine. So this is your regression equation when the like by formula and by the least square method. Now, if we want to calculate the correlation coefficient also from this. So let's see another cases like the question is asking for the correlation coefficient also. So then the R is equal to, so R from regression equation, from the regression coefficient, we can also find the R. So which will be equal to Bxy into Byx and the complete under the root. So that becomes the formula for the correlation coefficient, which says R is equal to Bxy into Byx complete under the root. So this becomes your regression coefficient. Sorry, correlation coefficient Bxy into Byx whole raised to the power 0.5. That means under root of Bxy into Byx. So if in this particular question, if we want to calculate the value of R, so R is equal to what will be the value of Bxy we have calculated? 1 is 6.60. So R value is Bxy. So Bxy we have calculated as xy is 0.143149. So 0.143149. So that will be the value of Bxy multiply by 6.6084. So this becomes your now the under root of the same. So which will be equal to 0.945986 raised to the power 0.5. So 0.972618, that will be the answer for the correlation coefficient. So correlation comes out to be 0.97216 between the two variables, which shows a high positive correlation, and the data is also showing the high positive correlation as the each and every value like will be, this is also like more or less increasing, and this is also like each and every value is increasing in all. So it will be high positive correlation in that case. So the R value shows the high positive correlation among the two. Clear? And this regression can be like more than one or less than one. Here the correlation value is always lies between -1 to 1, but regression is like 6.60, so which is more than 1. So regression can be there. But the condition is if one regression coefficient is more than 1, other has to be less than 1. Because otherwise, if both the answers are like greater than 1 for regression coefficients, then the number greater than 1 multiply by number greater than 1, the answer is also like greater than 1, and we have to take the under root, it becomes like more than 1 also, so which is not possible. So hence it is a condition for regression coefficient. The properties are, if 1 is greater than 1, if one regression coefficient is greater than 1, other has to be less than 1. Another condition is like, if one regression coefficient is negative, another has to be also be a negative, because under root of negative into positive, one is positive, one is negative, multiplication becomes negative, and under root of negative is not defined, is a not real number. So that's why the condition is either the two regression coefficient must be of the positives or must be negatives, because negative into negative is also positive, positive into positive is also positive. So either the two must be positives or either the two must be negative, so either they have to be a same sign. If one regression coefficient comes out to be positive and other is negative, that means we have done something wrong. So there is certain wrong in the calculation, that one is showing positive and one coefficient is showing negative. So it is not possible again. Clear? So on that basis, we have to do the next like thing, in which we are given with the regression lines. We want to find the values of like x and y, or the mean or regression coefficients. Clear? हमें regression lines given है, so we want to find the values of x and y from that. So let's take the example for that. So let's again, we have the two regression lines, 2x plus 3y is equal to 66, and 6x about this is your second line. So these are the two regression lines given to you. You want to find the values of like regression coefficients out of it. So इसमें से regression coefficients की values निकालनी है. So if we know that, so it is simple to calculate the regression coefficients from it. So regression coefficient from it we can find out by, we can quickly compare it. So like suppose if first line is x on y, so we can make x on one side and every rest thing on the other side. So this becomes 66 minus 3y. If the line is x on y, we become x on one and all things on the other. So 2x is equal to 66 minus 3y, and this x is equal to 33 minus 1.5 y. So this becomes the equation. And now if we are comparing this on x on y, the coefficient becomes, so bxy value comes out to be minus 1.5. So it's simple is like bxy value is minus of 1.5. Clear? And if this is x on y, so but obviously if this line is x on y, so this is y on x. If this is x on y, so but obviously those two lines are there, so this is x y on x. So if this is y on x, we'll take y on one side. So 9y is equal to 40 minus 6x, and y is equal to 40 by 9 minus of 6 by 9 x. 6 by 9 means 2 by 3. So this becomes your y on x line. So byx becomes the coefficient of x. So byx is equal to minus of 2 by 3 means 0.667. Fine. So now the thing we have calculated, but the thing is, if how we can identify, I am saying that this line is x on y and this line is y on x. So it can be also like this. It can be like this. If this is given to in the question, if it can be this case also, we have supposed the case has to be this, that the first line is x on y, another line is y on x. But it can be possible that the first line is y on x, the another line one is x on y. So we have to take the both the cases. So we have calculated for the first case. Now for the second case, like the first line is y on x. So y on the one side and rest on the other. So 3y is equal to 66 minus 2x, and y is equal to 22 minus 2 by 3. 2 by 3 is again 0.667x. So this becomes your y on x equation. And if the second line is x on y, so x on the one side, so which will be equal to 6x is equal to 40 minus 9y. And x is equal to 40 by 6 minus 9 by 6y. So 9 by 6 means 3 by 2y. So here we can say that the regression coefficient byx comes out to be minus 0.667 and bxy is minus of 1.5. Fine. Now one case here it is like the both the cases will be accepted because we are taking a random example. But if we are taking the actual question, so this is the this is the two is all possible. If we're seeing the properties, so the both the answers are correct. Bxy both is negative. Here also the both her coefficients are negative. Here is one is greater than one, other is also one is greater than one, other is less than one. In that case also one is greater than one, other is less than one. So both the condition will satisfy in both the things. But because it is like we have made our own question, if we'll just take the actual data and the actual question, it is like one case is always rejected and one case is always accepted. Suppose the first case, the condition is like the first case is not possible. So our first supposition which we have made is wrong. Another one is right, and we can say that the coefficients regression coefficient will be like byx is equal to 0.667 and bxy is equal to minus 1.5. Fine. So in that way, we can find out this regression equation and the regression line. So this will end your regression coefficients and regression lines, the concept of regression, how the one is related to the other, and all that. So that's why this regression is only the extension of correlation, in which the regression will also tell the cause and effect relation among the two. So which will explain the cause and effect also, which the correlation will does not tell. Fine. And if we'll talk of the continuous grouped data, so continuous grouped data is also like the same. The only change in, as we have did yesterday, the continuous grouped data for correlation. So the only thing is in that the same thing it is repeating, but the thing is only we have to calculate for only X term, not for the Y term. Because the way to calculate the same is like similar to the two things, but here we are not doing the Y calculation, we are doing only to the X one. It's only confined to X, not on the Y, so that will be your. So either it is a grouped data, so concept will remain the same as that of a correlation. Only the thing is there is slight variation in the formula for regression. We have to apply that regression formula and can do the same. So that will be your regression for like two variables. So, but if we have more than two variables, so that is a multiple regression. If we have more than one independent variable, that becomes your multiple regression. But that is like a complexity involved in that, because what that complexity is like, the two independent variables must be like, should be independent, but they can be like a collinearity between them. So the problem in like a multiple regression, why we cannot do into the manual way is like, suppose we'll take the same example as we have did here before also. Like I want to see the effect of my teaching on your performance. So here is your performance is your dependent variable and my teaching is my independent variable. My teaching is independent and your performance is your dependent. So I want to analyze the effect of my teaching on your performance. So your performance is dependent and my teaching is independent. So I want to find out the regression line as performance is equal to A plus B by X teaching. So that becomes the regression line, where intercept is like, if my teaching is zero also, then there is certain performance of you. So that is your intercept. And I want to see the effect of teaching on the performance. But there is one independent variable we have selected, but another independent variable can be your IQ. Another variable, independent variable can be IQ also, which affects the performance. So I want to analyze the multiple by performance is equal to A plus BXY teaching plus BXZ aptitude plus BXP maybe IQ or something. So they have an n number of variables which can affect the performance of the individual. Environment also affect. The infrastructure may be something, sometimes also affect your performance. So there will be n number of factors. So IQ is there, teaching quality is there, infrastructure is there, quality of the study material is there. So there will be n number of factors that may affect your performance. So, but the problem in the multiple regression is like, so the independent variable must be independent to each other. But if I am saying that IQ or like aptitude, we are taking the two variables, one is the aptitude and one is the IQ. So there is a collinearity between the aptitude and IQ also. We can say that if the person has a high IQ, has a high aptitude also. So that will disturb the regression part. So to control that thing, we need a software to calculate the multiple regression. We cannot do this. With this reason, we cannot do the manually like simple linear regression. We can only do the manual on the simple linear regression. We cannot do the multiple regression on the manual thing. So to curb this multi-collinearity between the independent variables, we need a software called like SPSS or Excel something. To do the multiple regression, we cannot do it with the manual way. So in the manually, we can only calculate this simple linear regression, but the concept will remain the same. How the interpretation of the same is that this is the same as the concept will clear from this regression test. So that will be your regression analysis.